Hello friends, welcome to EC Academy. In this lecture, let us understand canonical form of Boolean equations. Here, we'll understand what is canonical form and its two types of equations, which is sum of product, commonly known as SOP form, and product of sum, commonly known as POS form. To understand the canonical form, let us consider this truth table as an example. Here, we have three variables a, b and c which act as inputs, and we have function f which represents the output for different combinations of this input. Each row in this truth table represents a possible combinations of inputs, and the corresponding output values will tell us whether the function is 0 or 1. Our main focus will be to write this function in canonical form, which is sum of product and product of sum. First, let us understand canonical sum of products. So from this truth table, let us derive sum of product form. This sum of product is also known as minterm expressions. So to write the sum of product equation, we need to focus on the function where output is 1. So we need to concentrate on the output where f is equal to 1 to write sum of product, which is minterm expression. So we have output as 1 in this row where a is 0, b is 0 and c is 1. So the minterm will be a dash, b dash, c. So we have output as 1 for a is equal to 0, b is equal to 1, c is equal to 1. Therefore, we can write minterm as a dash, b, c. So here again we are having output as 1 for a is equal to 1, b is equal to 0 and c is equal to 1. So minterm will be a, b dash, c. Finally, in the last row we are having output as 1 for a is equal to 1, b is equal to 1 and c is equal to 1. So we can write minterm as a, b and c. So the canonical sum of product can be written as f of a comma b comma c will be equal to, so we'll consider all these minterm and we'll perform OR operation, and we can write a dash b dash c plus a dash b c plus a b dash c plus a b c. So this is the equation for canonical sum of product. So from this equation we can understand that the function is 1 whenever these minterms are true. Next, let us understand canonical product of sum. The product of sum is also known as Maxterms expressions, and this product of sum equation can be written when the function is equal to 0, which means for output is equal to 0, we can write the expression for product of sum. So if you observe the first row, output is 0 for a is equal to 0, b is equal to 0 and c is equal to 0. Therefore, we will write the Maxterms as a plus b plus c. Now you have understood the difference between the Maxterm and minterm. While writing the minterm, between each variable we will perform AND operation, and whenever the variable is 0, we will take the complement of that variable, and whenever the variable is 1, we will take the variable as it is. In Maxterm, we will perform OR operation between each variable which we consider, and whenever the variable is 0, we will take the variable as it is, and wherever the variable is 1, we will take the complement of that variable. So in this row, we are having output as 0 for a is equal to 0, b is equal to 1 and c is equal to 0. So we can write the Maxterm as a plus b dash plus c. So here if you can observe, Since b is equal to 1, we have taken the complement of b, and since a and c are 0, we have written the variable as it is. Here we are having output as 0 for a is equal to 1, b is equal to 0 and c is equal to 0. So corresponding max term, we can write it as a dash plus b plus c. So finally we are having output as 0 for a is equal to 1, b is equal to 1 and c is equal to 0. So we can write a dash plus b dash plus c. Now we can use these max terms and we can perform AND operation, and we can write the expression as f of a comma b comma c will be equal to a plus b plus c into a plus b dash plus c into a dash plus b plus c into a dash plus b dash plus c. So this is the expression for canonical product of sum. So you can see we are taking the product of sum of the input variables. That's why it is known as product of sum. So here you need to remember the SOP and POS form are the standard way of representing the Boolean equations, and these equations are helpful in digital logic design because these are standard way of representing the Boolean equations. This is about canonical form of Boolean equations. Hope you have understood the topic. Thank you.